Hello guys, so today we will be continuing from where we have left. So in our previous video, so we have worked on this HTML agent. Um so from that I have modified few changes. I have added some CSS lines. I thought like it's better to do it myself, not because all this thing will take some time, so I can give this code in a GitHub repo so you guys can use this code. But yeah, some background colors, padding, and some display formats I have changed, and few more changes I have done is on the. So earlier there was this bug. mm, yeah, earlier I was giving facing mode here directly. I should have used the FPS. Okay, so that was a bug from my end. And one more thing I have added is this part. This is basically a safety part. Okay, so earlier I was directly passing on like passing in room, but the thing is, uh, it may happen because I will be collecting this room string from the user, right? So it may happen there can be some spaces, or the user can enter some slashes and all that. So this encode URI format is a inbuilt JS format, JS function that basically remove all the unnecessary characters that are present in a string. And yeah, it just keeps like it's, you can say it's a safe function to encode whatever string we are passing into a proper URL param format. Cool. And other things like cool. I have changed this set status towards set pill. Now, why is it? Because I don't know. I just felt like, so I will show you the UI how it looks now. So maybe that will make some sense why I changed the name. But yeah, cool. Then one more thing I have added, like I have my Mac OS. There in Safari, I was not able to open up my camera. Okay, so it's basically they don't allow it. Okay, so yeah, I have added this check, like whenever I'm not able to access this media devices attribute from the navigator um, class, then I will simply alert the user like hey, this agent cannot run. So yeah, and I think one more change I did is on this part. So yeah, earlier I was directly putting the float number there itself, but um, yep. So now I am doing something like this. So let's clear this. Yeah, so I'm generating a math dot random number. Okay, this will give me this. Then when I'm converting to string, okay, this will give me this. But if I convert this number into base 36 format, okay, it gives me something like this. Now essentially I can use this part because this part comes out to be a alphanumeric string. Okay, and use that alphanumeric string to randomly put a device like get a, like put a device ID there itself. So yeah, so these are the chains. So like the complete change will be like slice to 7 this. Oh, okay, yeah, because yeah, it again call the random thing. Yeah, cool. So it gives me something this kind of alphanumeric thing. So if I show you guys how the agent looks now, Wails dev this. Cool. So the Wails server is up. Now let's look at our hub, how it looks. Clan this. Okay. Now if I do slash camera, so it looks something like this. Okay. Now let's try streaming it. Okay. If I click on this button, so yeah, my OBS is active, so I won't be able to do it, but I can do the same thing from my phone. Okay, so I have my phone here. So Now how will I access it? So my system and my phone are on the same Wi-Fi network, so as in like basically we are on the same network, so I can use my laptop's IP to access this. Okay, so this can be done something like this. Okay, so I am inside WSL, so WSL gives out its own IP address. So if you are using Windows plus WSL thing, so I will definitely recommend you to look at mirror networking. So in Windows, in WSL and Windows, yeah, basically you can follow the steps. So what will happen is, so uh, your WSL will not act as a separate network interface. It will basically bind your Windows network interface with the WSL interface. So all the servers that you are running in your WSL thing, so your Windows system will be able to access it. So yeah, I've already done it. So yeah, for my Windows and WSL IP, like these IP addresses are kind of same. So yeah, if I do look at my config, my IP address, so yeah, it's 192.168.0.100. But yeah, it changes every time. So right now I haven't made it as a static IP address, so yeah, this will change. So from my phone I can reach out to HTTP uh, colon slash slash 192.168.100.669 slash camera. Cool. So yeah, the page is open now. You can see the page here is open. So I can set all the configs, and yeah, so whatever I'm doing in my system, my phone can also render the same thing. Now if I try to access the camera, okay, it is popping up this message like it cannot access user media devices. Okay, now why this is happening? Because because our connection is not secured. So what is happening is uh, essentially this get user media thing, get user media, okay, from our navigator class. Let me check whether navigator is a class. It's an object, it's a global object. Yeah, so this guy doesn't work if our connection is like HTTP. Okay, we have to upgrade our connection to a HTTPS kind of a format. Okay, so in order to do that, we will be creating a SSL certificate. Okay, now how this certificate works is, so let's say you are into google.com. Okay, so when you send like when your browser searches for google.com, okay, uh, it passes through many DNS, then it's like one of the server responds back to the client and all that stuff happen. But on the client side, when the server responds, or I can show you something like this. Okay, so let's say I ping for a URL, let's say it's google.com. Okay, so from your DNS, it translates this domain name to a proper IP address. Then the server responds back with a certificate. Okay, now this certificate carries this information like whatever server is hosting this google.com, okay, that is trusted. Okay, this certificate is then read by your browser. Okay, now this certificate only comes if this server is behind a like is having a SSL certificate, or basically something kind of a HTTPS kind of a thing. Okay, now browser will check, okay, hey, okay, I think this server is genuine, so we can make a TCP connection and we can set up a session, okay, for later on whatever network request we will be making. Okay, then browser sends up a, you can say, a random key. Okay, okay, and this random key kind of act as a your session key. Okay, then server verifies that, okay, this client wants to make a request to me, so let's accept it. And yeah, after this your connections are made. Okay, then yeah, so after that whatever transports happen in between them, okay, that they uses the same session key, and all your data, like whatever is going from here to there, and now they are like wrapped, or you can say they are now encrypted. Okay, so all this data are now kind of encrypted data now. Okay, so during the session key generation, both generate some you can say some keys to decrypt their messages. But yeah, that's a lot of information, you guys can look at it. But yeah, essentially once this session is established, then they send encrypted data here and there. Okay, so whatever request we are making, those are like encrypted, and whatever responses we are getting, those are also encrypted responses. Okay, so any third party library which is like channelizing all this encryption, like a request, or let's say it kind of like, let's say there is a third party library which is acting as a relay, okay, in between our client and server. So when the client sends a request, this guy simply sends it to server. Now this guy cannot read it because the data is encrypted. Okay, but if our server is behind a HTTP, okay, then this encryption doesn't happen because we don't provide a certificate. Okay, and we force our browser to manually trust it. Okay, so this is where trust issues like happen, and due to that, this get user media has this rule that, because once this method is like active, then people can access like a camera, microphone of the users, right? So they can like simply collect like very private information you can think of. Okay, so yeah, that's why it uh, sets this rule, like whatever you are doing, if you want to use me, then your connection needs to be secured. So yeah, so in order to make this, we can simply do a hacky way. Okay, I will not call it hacky way, it's like a standard way, but I'm just calling it. Okay, because uh, this surveillance setup will be for our own network. Okay, so we can create a root authority. Okay, you can call it root authority, or we basically call it a certificate authority. Okay, now this guy will be uh, taking our IP address. Okay, now let's say whatever media I'm getting from that IP address. Okay, and the medium which is like sharing that media. So for example, let's say in my system, okay, I create a root authority. Okay, that is backed by my IP address. Okay, then I generate then for my server. Okay, for my this hub server, okay, which is running here. Okay, I essentially create a certificate for this server. Okay, and I sign this certificate via my root. Okay, it signs it. Okay, now if the server is sending a HTML page, okay, to my phone, Now, yeah, let's say this guy is sending a HTML page. Now whatever browser I'm using, that browser will see, hey, this this HTML page is coming from this IP address. Okay. Now before sending the HTML page, this guy will be sending the uh, this certificate also. Okay. So what will happen is, uh, so yeah, like right now how I did, so my hub was running there. Okay, so from my phone I send a request to my hub to fetch the camera. Okay, now when I'm sending this request, then the server will first reply to me with the certificate. Okay, now the browser will see that, oh, this certificate was signed by uh, some root authority, and that authority is backed by this IP address, and this is the same IP address from which I am collecting this HTML. Okay, because if you look at it, I am using this local host, but in my phone I use like 192.168. Okay, so my browser will see that, hey, the page is being uh, fetched from this IP address, and I can see this certificate was signed by a root user which is backed by this IP address also. Okay, so the browser will accept it. Okay, after that, all this user media, we will be able to access it, because right now our browser will trust this connection because of this certificate. Okay, and because of this root user. So yeah, and this is how we can set up a SSL certificate for our hub. Cool. So I will show you how you can do this. So you basically need to run a few commands in order to do it. Okay, so I'll just stop this server for now. Okay, I can close this, exit. Yeah, cool. So I have created a readme file for this. Okay, so first we need to create a RSA file. Okay, cool. So it will create this file. Now this file will be used to create a root certificate. Okay, and I will just give a name to my root certificate as camfield root certificate. Okay, and you can explore more of this command. So there are some like how to decrypt it. Okay, and what is validity. Okay, for now I am just keeping it like 10 years. Okay, but yeah, I will be removing all these keys. So yeah, cool. So I'm using this OpenSSL this. Now this will create a certificate file for me. Okay, and this will also be encrypted here. Now cool. So up to this, we have created this thing, our certificate authority. Okay, now yeah, and more on this OpenSSL thing. So if you guys are using Linux, so I'm guessing this library will be there in your system. If it's not there, just search for OpenSSL installer. Okay, and yeah, you will find something on the web. So because for me it was pre-installed in WSL. Okay, and if you guys are using WSL, so I don't think you will be having an issue. And I also think macOS has OpenSSL pre-installed. But yeah, if you guys are not finding it, please just search for it. I am guessing it will be pretty simple to install it. Okay, so yeah, so till now we have created the root authority. Okay, or root certificate authority. Okay, then I will be creating another private key. Okay, so let's create another private key. Cool. Then I need to create this file. So we call it subject alternative name config file. Now what is this is, so whenever we creating a certificate. Okay, so we basically need to first create a request. Okay, So let me just create this file. So nanosan.conf. Okay, I'll just copy paste this. So we have to create a request that, hey, I need to create a PEM file, okay, which is the certificate file, okay, and I will ask my root authority, hey, can you please sign it, okay. So these are some standard settings. I will not go through it, okay, but essentially what I am doing, you can see in the alternative name is that this. So I'm basically saying that use this certificate for my localhost connection, for my this loopback connection like to the localhost, and also use this certificate or like um, so use this certificate for my IP address also, 168.0.100. Okay, you can also pass some domain names also here if you are using some, but yeah, right now we are doing all this local setup, so yeah, I think this three will be sufficient. Okay, now yeah, this is something like a config for our certificate. Okay, you can think of this. So yeah, I will create this file, I will save it. Now I will be having a san.config here. Okay, cool. Now I will sign this certificate from by my root authority. Okay, so I will run this command. Now here I also need to pass my IP address 192.168.0.100. Cool. So yeah, now this should output me a certificate signing request file. Okay, and it will be using the SAN file that I have created. Okay, so this is my request file. Okay, and this is also encrypted. Okay, now I will be signing up this certificate request from my like by my root authority. Okay, so I'll be using this. Cool. So yeah, this should create cert.pem file. Okay, this is also an encrypted file. Okay, now my TLS connection. So this is a certificate that I will be sending to my browser. Okay, whenever the browser like a request for some resources to my server. Okay, now there is this command just to verify that whether this certificate is actually signed by this root certificate or not. Okay, so I can run this command. It should output me okay, something like that. So yeah, so indeed the certificate was signed by this root CA. Cool. So yeah, now I have this. Now I just need to change my server. Okay, my hub. Okay, so Golang provides us two things. So we can use listen and serve. This will be serving all our endpoints in a HTTP manner. Okay, and it also has another functionality which is TLS. Okay, like serve all the resources using a TLS connection. Okay, so here I just need to, like, if I hover over it, it asks me to provide the certificate file. So there I will be providing this cert.pem, and it asks me for the key file. Okay, this is the key file that I generated for my certificate, which is this file. Okay, so this key pem and this cert pem, these two files I just need to provide. So I will say cert pem. Okay, and then I will say key pem. Cool. So after this, so yeah, what else we what all things we did? We created a root authority. Okay, then we created a private key file. Okay, for our certificate. Then we created a certificate file which is signed by our root authority. Okay, since the root authority was backed by my IP address. Okay, so whenever I send this certificate to my browser will look like, hey, the certificate was sent by the same IP address, and the the authority was backed by the same IP address. Okay, so yeah, the browser will accept the connection, and it will trust the certificate, and we should be seeing the get user media error like should be resolved. Cool. So let's clear it. Now if I run Wails dev this, starting up the Wails server, done. Okay, now if I do https colon localhost slash camera, it should serve my page. Okay, you can see this thing is asking I can proceed with unsafe. Okay, cool. This is there. So right now you can see my local host is being served using https. Okay, which is great, because in my SAN I have mentioned that use this certificate for my local host also, so I can run my local host with https. Okay, now moment of truth. So this is what I was getting when I was using http. Okay, now I will switch to https. I hope you guys can see. Let me just verify whether you guys can see. Yeah, cool. Now I will just use https. Yeah, okay, I'll change it to https colon slash slash 168.camera. This yeah, now it is saying the same stuff which was like you guys just saw. Okay, like the connection is not private and all that. Okay, I'll click on advanced. I'll proceed to this. Okay, now if I click on start streaming, voila, now I can see my room in my camera. Okay, now if I flip this, let's flip it. Okay, just stop it, flip it, start streaming. Okay, cool. But yeah, essentially you guys should be able to see me. So yeah, so this is how you can access your camera in your phone, and you can access the get user media thing and bypass the HTTP layer check by creating this self signed like it's not self signed, but in an indirect way you can say like self signed certificate, because we are the one who created the root certificate. So yeah, I hope you learned something new in this video, and after this we will be working on this handle ingest thing. Okay, where whatever frames we are collecting from this agent, we will be processing it here and channelizing to all our viewers. Okay, and the viewers will be present in our Wails, uh, like in our Wails application. Cool then. So that's all for this video. Please do like and subscribe. Okay, it will motivate me to create more content. Okay, and yeah, good night guys.